Hi, today we are going to be talking about Chapter 7, Section 1. It's going to be adding and subtracting polynomials. Our goals today are going to be find the degree of polynomials, classify polynomials, add and subtract those polynomials, and show some real life examples. So, first of all, let's talk about monomials. A monomial is one term. And right here are some examples of monomials. You'll see that they could be made up of factors, but there's only one term. There's nothing that's separating them with like a plus or a minus. These over here are not monomials. We have a plus sign, we have a variable in the denominator, we've got an exponent as a variable, and we've got -1 as one of our exponents. So let's go ahead and do this first example. On this one, we want to find the degree of each monomial. Well, if the exponent is 2, the degree is 2. For B, the exponent is 1, the y is 1, 1 plus 3 is 4. For C, x is 3, y is 3, 3 plus 3 is 6. On D, we don't have a variable. You could think of it as x to the 0, because that would be 3 times 1. Anything to the 0 power is 1, and you get a degree of 0. So let's go ahead and do some extra examples of that. What you might want to do is pause and try these on your own and see how you do. First one is 1. 2 plus 2 is 4. 2 plus 1, don't forget the y has a 1, is 3. And the last one is 0. On the sheet that should be pushed out to you by your teachers, I'm going to be adding some extra videos to that. So if you want to see extra videos, there will be links there. All right, let's look at example 2. Example 2 is when we start classifying polynomials. So we're going to take a second and really just kind of look at this a little bit more in depth. So that polynomial is a monomial or sum of monomials. So they're going to have either pluses or minuses separating each term. The degree is going to be the highest exponent, and if we write it in standard form, you go from the highest exponent down to the lowest. Your leading coefficient is the number that's in front. Your constant term is what's being added or subtracted at the end. This core concept, I think it would probably be worth it to hit pause and write that down in your notes. Let's go ahead and look at example 2. We want to write this in standard form, identify the degree and leading coefficient of the polynomial. Well, the degree is -3. The first one is 1. Did I say -3? I was looking at that negative. I meant to say just 3. It owns that negative sign in front. So if we write this in standard form, you start with the highest degree, which is going to be -x cubed. Go to the next highest, positive 15x, and the least, which is 3. The leading coefficient is -1. You can think of that as a -1 in front of the x cubed. What I would suggest you do on this one is hit pause, try this one on your own, and see how you do. All right, let's look at example number 3, where we start classifying. When we classify these, there's going to be different ways that we can do it. A monomial is made up of one term, binomial is made up of two terms, trinomial is made up of three. You always want to write these in standard form, okay? So there's our original problem. There it is in standard form. The degree is 4, and that's a monomial. For B, there's our original problem. Write it in standard form with the highest exponent, 2, 1, none. The degree is going to be 2. You look at your leading term. And this is a trinomial because it's made up of 3 monomials. C, there's our original problem. Standard form, degree, and type. All right, what I would suggest, hit pause, try these on your own, and see how you do. All right, let's look at example number 4. On 4, we're going to start adding and subtracting. I will tell you right now, the key to this is combining like terms. For something to have a like term, it has to have the same exponent and the same variable. So 2x cubed and x cubed are like terms. There's 2 ways that you can do this. You can line things up vertically and you can line things up horizontally. We're going to do one of each. So when you line them up vertically, you're going to line up your like terms. My x cubes, my x squareds. My x didn't have anybody to line up with, so I leave a space. And here I didn't have a constant, so I just leave a space. If you are a real visual person, you might need to put a 1 in front of that x cubed, because 2 plus 1 gives me 3x cubed. Be careful of your signs. That's a -5. -5 plus 2 gives me -3. X plus nothing gives me x. Nothing plus -1 gives me -1. That is my final answer. For part B, we're going to do it horizontally. And this is how I typically do it. And they're going to write down the first step for you, but a lot of times I will do it in my head. Sometimes I'll even underline which ones are the like terms. So here is our original problem. If you notice, they wrote the first one in blue, the second one in red, and you're going to see why in just a second. If I combine the 3x squared and the x squared, they're doing it. And again, they're writing it down. If you were to just write 4x squared down right there, I think that would be fine. So 4x squared, 5x, positive 4. All right. On example 5, we're going to start talking about subtracting the polynomials. That gets a little bit trickier there because you're going to want to distribute that negative sign. It's really easy to make a mistake when subtracting. You have to work really carefully on this one. So on this one, we're going to do this one vertically, where we line everything up. And if you notice, we put parentheses around that second set of parentheses because we're subtracting everything there. What I do is I change that minus to a plus, and I distribute that negative sign. So that -2n squared becomes positive. That positive 2n becomes negative. The -4 becomes positive. Now it's just an adding problem where you combine your like terms. So there's our final answer. On B, we're going to do this one horizontally. And a lot of times I'll even just physically write that, make that a plus, and distribute the negative sign so that 3x squared becomes negative, the -x becomes positive, the -8 becomes positive. Change the sign of everything in your second set of parentheses. Now, you just combine your like terms. And you should get x squared minus 2x plus 13. What I would suggest you do is hit pause. I'm going to put these answers up in just a second, and you can try them on your own. All right, let's go to a word problem. Dropping a penny, and it's represented by this formula. Dropping a paintbrush, and it's represented by this formula. They want us to write a polynomial that represents the distance between the penny and the paintbrush after t seconds. Well, the key word there is the distance between. Right there, you're going to have to subtract. So you take your top distance minus your bottom distance, distribute your negative sign, and I got negative 40t plus 100. So that's really the distance between the two of them. And I think really what's the most important question here is interpret the coefficients of the polynomial in part A. Well, what that means is for each second, which is t, it's decreasing 40 feet. And that 100 is kind of where we're starting from, because if t was 0, you're going to have 100 feet in between. If you were to put 1 in there, you'd have 60 feet in between. So at 1 second, there's going to be 60 feet in between. All right, that is all I have for you today. I hope you enjoy.